We're going to start. Good afternoon, everyone. I'm glad to be here in Amsterdam. In case you're wondering why it is that I'm glad when it's so cloudy out, I come from Seattle, which is just as cloudy. So we're going to talk about the new Hyper-V Extensible switch. My name is Bob Combs. I'm a program manager in core networking, and more specifically, my team owns Hyper-V networking. So what are we going to cover today? We're going to talk a little bit about cloud and kind of what it means in terms of networking. We're going to talk about what's new in the Hyper-V Extensible switch, that is the virtual functionalities, as well as what is extensibility. We're really going to focus on extensibility. And then we're going to dive into a little bit more details of the particulars of it. And I really was born in the state of Missouri. It's the show me state, in case you don't know what that means. It means, hey, I want to see something real. So I have some good stuff here. I have several of our partners who are going to show off their real extensions and tell you a little bit about each one. And then I'm going to talk a little bit about how one goes about managing extensions. So to start with, here's the same slide that you're going to see at just about every server presentation. These are the key pillars, and the red box is showing you where we are in this talk. We're still talking about beyond virtualization. What happens with the cloud? How does the Hyper-V switch participate in this, and what does it actually mean for you? So let's talk a little bit about what does the cloud actually want. What kind of things do you have to do for the cloud, to enable the cloud to really exist, to allow you to move things into the cloud, be it private, hybrid, or what have you? Well, one thing is that you have to make sure that you have an integrated security mechanism built in. You have to be able to isolate traffic from one another. You have to be able to apply policies easily on a per VM basis and be able to actually segregate that from the other VMs. Because there's so much functionality that could be added, you need a way to add those additional traffic tools in there. And of course, you can't make the problem harder for yourself. You have to be able to have a simple, unified way of managing as much as you possibly can. The main thing that happens here is that the distinction between what's a physical network resource and a virtual resource is incredibly blurred. You really need to be able to treat the two resources as if they're one and the same type of concept. And that's really where we're headed. So, level set. The virtual switch is this box with the arrows here in the middle of the diagram. And what it's really showing you is that all of the virtual machines that reside on that host have a virtual NIC. I often refer to it as a VM NIC, virtual machine NIC. And all of their networking is going through that virtual switch. And then the virtual switch itself has connected to it either a team or a single NIC that's connected to your external connection. So let's start by talking a little bit about what things have we added to the switch that are new for Windows Server 2012. And we've added quite a bit. I've tried to group them into some categories here to make it a little bit easier to, hopefully, for you to memorize. One is isolation techniques and management of traffic flow. So one of the things we added was port ACLs, the ability to put an ACL on a port either by IPv4, IPv6, or MAC address. And it can be either an allow or a deny ACL. So that's one way. Of course, if you're really scaling large in a data center or enterprise, ACLs can get cumbersome to deal with. But there are simpler mechanisms that you can use, such as private VLANs. How many of you are familiar with the concept of private VLAN? Okay, a good number. For those of you who didn't raise your hand, either because you don't want to admit you don't know it, or maybe you really don't. I'll be honest with you, several years ago I didn't know. Private VLAN is a concept where it uses two VLAN addresses for your send and receive, and by judging them accordingly within the switch, you create three types of connections. It can be either a trusted connection, it could be a isolated connection, or it could be a community connection. Community connections can all talk to each other. So if I have two machines on the same PV LAN and they're both community, they can talk to each other. And they can talk to the trusted connection. If I have an isolated machine connected to it, the isolated means he can talk to the trusted, but he can't talk to other isolated, and he can't talk to any community. What this really lets you do is it lets you define several different architectures easily with just two VLANs. You can think of it as a very handy, easy way to save on your VLAN addresses because, you know, there's a limited number of them by today's standards. I guess I can give you a couple quick examples. One example might be that let's say I have a bunch of client machines and I want them all to be able to talk to the internet, but I don't want them to talk to each other. This is a typical scenario I've heard of in hosters. I've also heard of the same scenario in schools where I give each student their own virtual machine. They're running a client. I want them to have internet access, but I don't want them to talk to the outside world. And I really would hate to waste a VLAN per student, so I can use PVLAN to set up that architecture, and I can group all of them that way. Another thing that we put in is trunk mode. If you're using Hyper-V today, what you know is that if I wish to use VLANs, I can assign a VLAN per VM, but I can only assign one VLAN per VM. What happens if I want to have a virtual appliance where I want to process traffic from several VLANs and maybe then reroute it to the other VMs? Well, I need to be able to actually trunk multiple VLANs, and so that's what trunk mode is. It allows you to put multiple VLANs on that same VM. We've put in some traffic shaping capabilities, QoS, specifically bandwidth caps and bandwidth minimums. And we have the ability to do QoS as either a absolute bandwidth or as a percentage, a weight. The weight becomes handy if I'm talking about things like NIC teaming, where half of the team, or say a NIC fails in the team or it gets disconnected or something, and I want to reapportion the bandwidth without actually losing all the connections. In other words, if I had done absolute bandwidth on it, I'd have a potential problem that I might not have enough bandwidth to really go around. But if I used weights, I could redistribute the allocations based on that same weighting formula. A bandwidth minimum lets you say, I guarantee that this VM gets at least this much bandwidth. Bandwidth cap says this VM can't use more than this amount. In the case of the minimum, if other people aren't using the additional bandwidth that might potentially be available on the link, the VM is free to use it. In the case of a cap, it prevents it from using it. Security features. You might be familiar that in 2008 R2 server, SP1, we put in ARP poisoning protection. ARP poisoning protection makes sure that a particular machine can't do a man-in-the-middle attack by answering to ARP replies from another machine. We've added to that, and we put in router guard, and we put in DHCP guard. Router guard says you aren't going to let a particular VM forward traffic like a router, and DHCP guard really says this VM cannot act like a DHCP server. He's not allowed, if he attempts to respond to as if he's the DHCP server or to otherwise query as if he were the DHCP server, those packets will be dropped by the virtual switch. IPsec is a functionality, of course, that's been in Windows for a while. What we've done in 2012 is we've actually chained the ability for a virtual machine to do a IPsec task offload all the way through the virtual switch down to the hardware. So now, for efficiency's sake, he's actually putting the security encryption back using the engine that's on the NIC. So that's a performance boost to the system. Speaking of performance boost, we put in dynamic VMQ. We had VMQ before. What we've done is we said, you know what? Let's scale this up and down. VMQ can handle multiple processors and will distribute the traffic around, multiple cores for the host, for the virtual switch. But what happens is, if there's very little traffic going through, it actually costs something to distribute the traffic, and it became inefficient. We said, well, we can gain some back by just making sure that it's dynamic. In other words, it'll go down to using one core if there's only a little bit of traffic. As traffic increases, it'll add the cores that it's allowed to within the range that it's given. There are no switches to turn on dynamic VMQ. If you turn on VMQ, it's dynamic by default in 2012. We added single root I/O virtualization. Single root I/O virtualization is the ability for a virtual machine to talk directly to the NIC card. We're assuming, of course, that the NIC card is SRIOV capable. Normally, so instead of taking the software path through the switch, it would talk directly to the NIC, and that's a performance boost. It's actually a rather significant performance boost. It'll actually reduce your CPU utilization. It will reduce the latency because it's not going through the switch. It will, because of those other two, actually increase the overall throughput that the network card is getting. The downside of it is that since it's bypassing the virtual switch, all of these other policies that are listed here wouldn't get enforced. So if you have, if SRIOV is allocated on a particular channel and you add a policy, let's say I put a QoS policy or an ACL on that VM port, then it will actually revert it back to the software switch to make sure that the SLA is guaranteed. A couple of different diagnostics. Port mirroring. We actually can, you can actually pick multiple ports that you essentially want to take and make a copy of all that traffic and send it over to a monitoring port. This would be handy if you were building a intrusion detection system, for example. There are other virtual appliance type constructs that you can think of where you might use something like that. Diagnostics. We had event tracing and unified tracing before, but what we've actually done is we've chained those all the way through the switch and made it available even on the edges of the extensions. We've also added some capabilities that will make it easier to turn those things on and off. And we have other diagnostics that we added in, some new perf counters which track the number of packets that were dropped either by the switch itself from any of these policies or by the extensions based upon whatever their policies are. So it's two counters that were added in that can be monitored. That'll let you watch these things and then decide when you want to actually turn on either event tracing or unified tracing to see what's actually going on. But that isn't all we did. We said, no, you know what? We've thought of a lot here. This was a lot for us to get into this release. We said, you know what? There's third parties out there that have a lot of good products, a lot of good ideas. There's got to be a way to expand and allow that functionality to be enjoyed by the customers. So we came up with the idea of a Hyper-V extensible switch. So the extensible switch allows multiple extensions to be added into the switch. And I'll go through exactly the different types of extensions, et cetera, as we go through this. Extensibility is a nice, simple way to add the functionality into the switch and to expose it in such a way that if I'm sending traffic virtual machine to virtual machine, that those extensions can put that those restrictions or those capabilities in for that traffic as well as traffic that went out. Previously, you had to put all of the filters, et cetera, below the switch, which of course only allowed you to look at traffic that was going external. It didn't talk about traffic that was going VM to VM. So you really wanted that switch to be extensible. So the tenets that we looked at, what we wanted to make sure that we were capable of meeting, and this is kind of where we started in the very beginning when we started thinking about this, are kind of listed here. So one of the first things we looked at was the competition had, other hypervisors had the ability to replace the switch. But that meant that if you wanted to add a very simple functionality, you had to rewrite the entire switch. It also meant that in the case of any hypervisor system, that every developer would have to learn how to talk to the various buses that the hypervisor used. Like in our case, it's the VM bus or the virtual PCI bus. We said that seemed kind of heavyweight. Let's just make it extensible. And as I mentioned before, we made it pluggable so that we could get in the middle of that VM to VM traffic. And moreover, to make sure that if you do multiple extensions in there, that they don't eat away at each other. They rather add functionality. In other words, all of the functionality we put into the base switch is there, even if you add extensions. And as each extension is added, it's just adding functionality. It's not taking anything away. Another interesting aspect of having extensions is that the code footprint's actually a little bit smaller. Making that code footprint smaller actually makes it easier for everyone to make sure that less errors creep into the system. First-class citizen of the system, what we meant by that was an extension should not have to re-implement functionality to do, say, NIC card offloads or to do live migration. Those should happen for free. The framework should supply that. We used open and public API models. More specifically, all of the networking drivers and filters are written to a specification called NDIS, Network Driver Interface Specification. We use that exact same API set again. There's another one that we use as well, the Windows filtering platform, which a lot of third parties use for building firewalls and the like. We made sure that that API set was also available for extension writers. In other words, there's no new APIs that were being forced out of this. And of course, quality is important. And the way you get quality is to make sure that there's a rigorous set of tests that certify that the extension is behaving as it should within the right framework. Obviously, you can't test the functionality, but you can test to make sure that it behaves well in the system. And that's exactly what our logo certification program has been built to do. I mentioned the unified tracing, the event tracing before. And one of the key benefits of that is the fact that it does mean that when something goes wrong, the downtime is shorter, easier and quicker to diagnose. So those are the key tenets. So let's kind of go back to this and talk about these things. I've mentioned already that we've made these as either NDIS filters or Windows filtering platform providers, but in the end, we just refer to these as extensions. And I'm going to go through each one in a little bit more detail. The other thing I guess I want to mention here too is that each extension can have its own custom configuration properties, and those properties are managed within the framework of the extensible switch and within the framework of VMM in such a way that if you go to do live migration, as I mentioned before, those settings, those configuration values, are migrated with the extension over to the destination target. Okay, so another little side note here. There is a version of SCVMM 2012 SP1 coming, which will manage Windows Server 2012, and that includes managing extensions. It has the ability to, third parties actually can stick in some components around this. You'll notice kind of in the lower right-hand corner underneath the red VMM service, there's a vendor SCVMM plugin. That is one of the places where information can be leaked into the, or I should say configuration can be leaked into the VMM and used to actually help manage the extensions. So when a third party writes an extension, like the capture extension, filter extension, forwarding extension, we'll go through the types in a minute, that vendor plugin helps SCVMM become smarter about how it manages that extension. So SCVMM will actually be able to deploy the extensions along with the Hyper-V switch, just like it can deploy the hosts, etc. And it can also, through using the use of WSUS, will actually be able to manage updates of extensions as they come out. Okay, so let me start talking about the different types of extensions. So the first one to talk about is the capture extension. And we've defined 3 classes of extensions. And the purpose of having these classes was to make sure that we could not only order the traffic, or order the extensions in the way they process the information, but also to make sure that you put the right restrictions, if you will, around the different types of extensions. So a capture extension, if you can think of something like network intelligence. I want to look at traffic. Don't really want to touch it. Don't want to modify it. Don't want to alter it or drop it in any way or block it. All I want to do is I want to watch that traffic and then take that information and use that to present a picture to the administrator of what's going on in the network. So that's what a capture extension does. A capture extension, there can be multiple capture extensions of the same, within that class, doing different functionalities. And I'm going to play you a quick little video.
You can install the Hyper-V S-Flow agent on individual systems using a traditional installer. Alternatively, you can use the System Center Virtual Machine Manager to deploy and configure the S-Flow agent on all the Hyper-V systems across your data center.
This is a quick preview of System Center 2012 SP1, how it works with extensions.
Once the S-Flow agent has been installed, you can use the Virtual Switch Manager to verify that the packet sampling filter has been installed and enabled. The Hyper-V S-Flow agent continuously monitors the performance of the Hyper-V host itself together with its virtual machines. It also monitors the performance of the virtual network, including the overall utilization and the traffic flows. A single S-Flow collector can be used to collect S-Flow data from all other Hyper-V S-Flow agents within your cloud or data center. Here we're using the S-Flow Trend S-Flow collector just to monitor a single Hyper-V host. Here we are looking at the data that's being collected. We have one Hyper-V host which has 2 virtual machines set up on it, and here we are looking at the CPU statistics. There are a number of other summary screens. For example, we can look at the memory utilization. We can also look at the network I/O. Drilling down, we can look at the trend in network I/O over a period of time. The Hyper-V S-Flow agent also exports detailed information about the traffic flowing through the virtual switch, so you can monitor activity between virtual machines within a single host. In this example, we've set up an HTTP session between Windows 8 client and an IIS virtual machine. And here in this view, you can see exactly that traffic flowing through the virtual switch. The S-Flow standard provides complete visibility. The architecture consists of simple agents sending raw measurements to a central collector. The combination of traffic measurements from the high-speed switch fabric, system management metrics from the servers, inter-VM traffic measurements from the virtual switches, virtual machine performance metrics from the hypervisor, and actual application transaction monitoring provides a detailed picture of overall cloud performance.
Okay, so this was a really good example. This is a real example. Inmon actually has built this extension of network intelligence gathering. Okay, so let me move on to the next type, filtering extensions. So filter extensions are much like capture extensions, but they can do a little bit more. As the name would imply, they can filter the traffic. They can examine it, they can drop packets, they can modify packets, they can inject packets. The thing they can't do is they can't do forwarding. So that's the third type, and we'll talk about that in a minute. But before we get there, I want to talk about something a little bit more, and that is we've actually built a extension, a Microsoft extension, that connects to the WFP, providing that, as I mentioned before. So the WFP is the Windows filtering platform, and again, it has the same capabilities of doing inspect, drop, modify, and inject packets, but it's a little easier of an API set. The NDIS API is a very rich and detailed API set, but if you really want to be able to build something like a firewall or whatnot, you can actually use the WFP a little bit easier. And so some of the partners who've actually moved in that direction are going down that direction. With that, I'd like to get an example shown to you, and we have Konstantin Malkov from 5.9 here to show us his extension, Virtual Firewall, which he's got downstairs in the demo hall.
Five9 Software, I'm Konstantin Malkov. I'm CTO of a company called Five9 Software. We're headquartered in New York Metro, New Jersey, developing management and security and compliance applications for Microsoft Server 2008, 2012, and Hyper-V. We have several free tools, which are quite popular. Five9 Manager for Hyper-V, that provides local graphical user interface for Windows Server Core Edition and Microsoft Hyper-V Server, cloud monitoring tools, V2V conversion tools such as VMware to Easy Converter to Hyper-V, which is also a free tool. And our flagship product is the one that Bob has mentioned. It's Five9 Security Manager. About 2 weeks ago at TechEd in Orlando, we announced beta preview of version 3, which is specifically designed for Windows Server 2012 and Hyper-V Server 2012. It's a completely agentless firewall versus the current version, which is being shipped right now. It's a combination of virtual firewall and anti-malware software, quite popular among hosting companies because they have to perform actions like Bob mentioned, separate virtual machines when they deploy them, allow traffic between certain virtual machines, and or disallow it for certain protocols, ports, and things like this, as well as perform logging, deep packet inspections, and of course, run the anti-malware scans in such a manner that you avoid antivirus storms. The previous version, the current version, which is being shipped right now, is agent-based because there was no way with the current Hyper-V architecture to create an agentless solution. With the new Hyper-V switch and Windows filtering platform, we were able to create very elegant and powerful firewall solution that basically it gets installed as and I'm going to show it. It is a live demo. We're connected to our lab server. You could see that it shows it as a sub-extension to Microsoft Windows filtering platform. So basically it gets installed inside Microsoft switch. And there's a simple configuration here. There are 3 virtual machines. And right now you could see by default all of the traffic between virtual machines and outside world is blocked. Here I created 2 allowing rules. So we're going to go here to this virtual machine and try to ping another virtual machine. Here's 1.7 as an IP address for a second virtual machine. You can see that traffic is going through. If I would go here to virtual machine 2 and say block ICMP traffic and try to do the same thing, you could see that the traffic obviously times out. Similar thing could be done if I try to access either virtual machine 1 from virtual machine 2 or vice versa, or host from virtual machine. In this case, I'm going to do HTTP access of the host. Here's IP address for the host. And if we go here and try to access host from virtual machine 1, you could see that, this web page is accessible. This is because we have a allowing rule for port 80. If I would go here and I would say block instead of allow, and try to perform the same. To access the same page. It's blocked. So basically, the system allows you to programmatically control security and traffic between virtual machines or between virtual machine and host, and it installs as an extension to Hyper-V, new Hyper-V virtual switch.
So the key benefit that you're pointing out is that previously you had to install something on every virtual machine in order to enforce the same filtering. Right. Now you can do it all in a central location, which also means the filtering applies regardless of the OS running in the VMs.
Right, exactly. And system allows you obviously to log all of the events. There are different options and retaining options for the logs. They could be either stored in the database or flat files, and this is very important for enterprises and hosting companies for compliance purposes, obviously. One thing I also wanted to mention is that as a part of a new version of Security Manager, we created an anti-malware, which is also very unique because it's agentless. So you could, all of the antivirus scans, which could be either ran on demand for virtual machines or, could be started on schedule. They actually performed from either appliance or the host, so you don't have to put anti-malware agent inside the virtual machine, which also allows you to, it's much easier to manage. There's much less, possibility of antivirus storm, and it's performed by unique technology. We create a special antivirus snapshot, which you could see for each of the virtual machines here as soon as the antivirus gets started. And after cleanup is performed, there is a quite unique technique how you replace original virtual machine with the one that has been cleaned up. So, to summarize, new architecture of Hyper-V switch is really elegant and allowed us to create the solution that, is important from the standpoint of network security. Thank you.
So, Konstantin, is there a place where they can actually download and try the beta of your software?
Oh, yes, absolutely. If you, first of all, you can stop by at our booth, which is in Microsoft Partner Pavilion, booth number 24, right after this session and tomorrow. And you also can go to our website, which is 59.com. It's just like it's shown here on the slide, 59.com. And if you go into the products menu, the first menu is register for the preview of version 3. If you go into communities, webinars, you're going to see a bunch of videos that show all of the features. Thank you.
Okay. Thank you very much, Konstantin.
Thank you. Thanks, Bob.
Okay. So, we've talked about capture extensions, showed you a quick example, talked about filtering and WFP, showed you a real example. Now I want to talk about forwarding extensions. That's the third class. Now, the forwarding extension is a little bit unique. Whereas you can have multiple capture and multiple filtering extensions, there can be only one forwarding extension. And the reason is kind of simple. The forwarding extension computes the routing for the Hyper-V switch. If there isn't a forwarding extension, you get the Microsoft virtual switch routing. But if you... Pardon? Yeah, okay. Technically, it's computing the routing table, the distribution table, correct? Now, switching is a layer 2 switch. essentially. Okay, so, but more to the point, the algorithm itself is actually being turned off and delegated over to the forwarding extension to do the computation of the distribution table. And in addition, that means that the forwarding extension also assumes the management of VLANs as well, because that's actually part of the calculations for the distribution. There can only be one of those, because if you had two, clearly that wouldn't work. So the switch won't really allow that. That said, there's nothing to prevent someone from actually creating multiple forwarding extensions for different networks on the same host and using a different forwarding extension on each one. And if you did that, if you went in and looked in the Hyper-V manager, you would see multiple extensions, but only one could be checked, only one forwarding extension could be checked and enabled. And we have a couple examples of this. So I'd like to ask Soo-Hun Yoon from NEC if he could come up and show us their OpenFlow Hyper-V extension. Thank you. Okay, you need to switch. Didn't take you three. Hold on. There we go.
Hello, thank you, Bob. My name is Soo-Hun Yoon from NEC. So today I would like to talk about the OpenFlow and software-defined network solution for Hyper-V. So OpenFlow is a new emerging technology between the switch and controllers. So it basically separates the data plane and the control plane. So the single controller can manage the multiple switches forwarding tables using OpenFlow protocol, so which is standardized by the Open Networking Foundations. NEC is a leader in OpenFlow community, and we have been shipping the commercial products in both controller and then physical switches. So today I'm happy to announce that we are going to also provide the software-based virtual switch for Hyper-V. Today I would like to show you some demo for using the Extensible voice switch forwarding extensions. So today this is an overview of my demo. We have two Windows 2012 servers with NEC's OpenFlow extensions. Then we have physical switches and firewall. Then these virtual switch and physical switches controlled by the NEC's programmable controllers using OpenFlow protocols. Then, assuming we have one security policy that from the traffic VM1 have to go through the firewall first, then go to the destination virtual machine. Then, to do that, the program flow controller established such a forwarding table in the all the switches from virtual switch to the physical switch. So the traffic will be redirected to the firewall and go to the destination virtual machine. Then if the VM migration is happening in this environment, then VM2 migrates to the server 1. It becomes a local communication on top of this in these servers. Then sometimes it's difficult to go through the traffic to the firewall. So our controller can set up the forwarding table in the switches. Then it will redirect all the traffic, go through the firewall and back to the destination virtual machine. So I would like to show this use case in the demo. Then my demo is captured by the video in the TechEd in North America in 2 weeks ago. So we have a Hyper-V manager. Then Hyper-V switch manager will show you that NEC OpenFlow extension is enabled here. Right. Then next window is Microsoft Failover Cluster Managers. Then you can see the two virtual machines are running. Then virtual machine is sending the streaming data. The next window is a Programmer Pro Controllers Management Consoles. So this basically shows you the physical topology view and logical topology view. Then today I'm going to focus on the physical topology view. Then our controller automatically discovers both physical switch and virtual switches, and then visualize physical connectivities. So now you can see the one physical switches and two virtual switches. Then there is a firewall input port and output port. Then you see the virtual machine is connected to the virtual switches. Then it also visualizes the data flows in the network. Then this is a list of the flow, and then each flow will be visualized on the blue arrows. Then right now, it visualizes traffic from the virtual machine 1, go to the virtual switch, then physical switch, and then finally go to the firewall input port. Then this visualization is managed by the controllers. Then second data flow is from the firewall's output port, then back to the physical switch, and go to the next virtual switch, then and go to the destination virtual machine. Then third flow is reverse flows from virtual machine 2, virtual machine 1. Then you can see the third flow directly go back to the virtual machine without stopping by the firewall. So controller can set up this kind of the flow based on the user's policies. So now I'm going to migrate this virtual machine from here to another servers. Right? Then back to the Hyper-V Manager windows. Then specify the virtual machines and select a VM, and then live migration, then the node. Then we can decide which destination server migrate. Then it will show you the progress of the live migration. And then during the migration, the virtual machine keeps sending the streaming data to the destination. So there is no service interruptions. Then now the live migration is completed. So back to the controller's management console. Right? Then it also automatically detects this virtual migration. So the virtual machine, it was here, now it's here. Then first flow still go to the firewall through the both virtual switch and physical switches. Then second flow will be back to the this virtual machine, and then based on the VM migrations. Then the third flow is a reverse direction, so it directly go back to the virtual machine 1. So this kind of the flow control is done by the Programmer Pro Controller in the centralized way. Then user can keep a single security policy which is independent from where the virtual machines are allocated. Okay. So this is my demo. And then once again, so NEC is very happy to provide the open flow solution to the Hyper-V environment. Thank you.
Thank you very much. Okay. Well, I got more forwarding extensions to show you about, and Timothy Ma is here from Cisco to tell us about a extension for the UCS system. Make sure your laptop's up. You hit. There you go. Apparently he wouldn't share his password with him.
No.
Hello. So, got a little bit technical difficulty, but good afternoon, everyone. My name is Timothy Ma from Cisco Systems. Majorly focused on the Unified Computing System product line. So today I'm going to do a video demonstrating. This video is also captured 2 weeks ago from the North American TechEd. So Microsoft and Cisco have been jointly develop a VMFX technology together. VMFX stands for Virtual Machine Fabric Extender. And the purpose of VMFX is help the user to basically centralize, configure virtual machine network policy. For example, QoS for the individual virtual machine, and then across multiple Hyper-V hosts, but managed centrally together. So so let's start with taking a look at from the UCS systems. So UCS system is the Cisco server management instance. So but it's not only just the server intelligence control, but also it has multiple functions, including administrator can configure your LAN, your SAN, also your virtual machine policy, all together in this single pane of glasses. So let's start taking a look at more detail on the UCS managers. So on the UCS manager, we have several tabs. The first tab we have is the equipment tabs that basically showing the hardware characteristic of the server. The second tab we have is the server tab. It's basically let the user describe a logical function of a server. And the reason is we would like to decouple the physical server from the logical instance, so we can apply this logical instance to multiple physical server for multiple purpose. In this particular server environment, we have a service profile that configured with 4 static NIC, and it serves as a physical function in the ISRV environment. And underneath each static NIC, we also have multiple dynamic NIC created. And each individual dynamic NIC is served as a virtual functioning for the SRV mapping within the individual virtual machine. The next tab we have is the virtual machine tab. That's basically where the profile for the network policy is centrally created. And here we have pre-provisioned a profile called engineering. And within this profile, administrator can configure various policy, including QoS, including network control policy, your uplink pin group, and also your VLAN modification as well. Once the profile policy is configured, it will be centrally managed underneath a Hyper-V cluster, which is connected to the SVMM 2012 SP1. And once we complete the configurations, the UCSM will have the visibility down to the individual virtual machine level, which is VMFX enabled and has the visibility to its NIC, MAC address, and also the VLAN that's configured on the virtual machine as well. So let's take a look at it from the SVMM side and how we complete the configurations. In the SVMM configuration, first we have pre-provisioned 2 Hyper-V hosts that underneath one host group. And then we're moving on to the switch extension manager. Inside the switch extension manager, it's where the UCS manager talks to SVMM. And underneath the switch manager is actually where we install the switch extension. And as Bob mentioned earlier, it's a forwarding extension, and you can only enable 1 per Hyper-V host.
Per switch instance.
Per instance, yeah. And next, we have pre-configured a logical switch we call the SJC network. And this logical switch will inherit the switch extension that we previously provided, and also the host group that we are select for the desired host. And also for the logical network, we can also provide the default virtual port policy. In this case, we'll have SRLV enable for all the virtual machines that connect to this particular logical switch. The ISRV can be enabled centrally through the virtual port policy, or we can go to the individual VM and enable on a per adapter basis as well. So let's take a look at from the host side for the configuration. So in the individual Hyper-V host, as you can see, from the hardware configuration, we'll see the same 4 physical NIC act as a physical function. And we'll also be able to see underneath the virtual switch will attach to the virtual switch that we just created on this particular host. And as we mentioned earlier, the idea of VMFAX is we want to centrally create the port profile policy, the port profile for the virtual machine, and propagate to the SVMM as a tenant network. And here you can see we configure the port profile for engineering, and it's propagated to the SVMN as a tenant network for the administrator to apply to the individual virtual machine. Within individual virtual machine, if we go to the hardware tab and underneath the network setting, we'll be able to see all the information that will be configured so far. So we'll have this virtual machine attached to the engineering tenant network, and we'll also attach this particular virtual machine to the logical switch that we created and has ISRV capable, enabled already. So next, I'm going to show a quick video demo as well on how can we utilize this VMFX technology developed by Cisco and Microsoft in the real-world scenario. So in this particular demo, what I have set up is I have 2 virtual machines set up. Both are SRLV capable, and as you can see from the test manager, I have 4 10 gig adapter configured and it's running at 40 gig throughput VM to VM. And basically the idea is we want to be, for example, we want to modify the QoS policy. I want to rate limit one of the adapters from 10 gig to 1 gig without interrupt any services. How can I do that? By utilizing the VMFX technology. To achieve the goal, it's very easy. All we need to do is we go back to the UCS manager that has previously shown, and we can find the corresponding port profile, select that corresponding port profile, and modify the QoS policy to the desired one. In this cases, we'll change from Platinum to Silver. Silver has a rate limit of 1 gig. We apply the changing, and then we go back to the virtual machine and observe in the test manager. We can see that one of the adapters is immediately dropped to 1 gig. This process doesn't require any reboot of VM, and it doesn't interrupt your current service. Thank you.
Great. Thanks, Timothy.
Thank you, Bob.
Spencer. Okay. So one of the nice things I think you saw there is that's a little bit more preview of SCVMM 2012 SP1 and how it's going to manage extensions. So I have one more extension that I wish to show you. Apogee Mala is going to come up and tell us about the Cisco Nexus 1000V for the Hyper-V switch.
Thank you, Bob.
Kick you right back.
Thank you very much. Cisco announced 2 solutions around virtual networking for Hyper-V. And one of the solutions is a hardware-based solution, that's the VMFX, Virtual Machine Fabric Extender, that Tim showcased just a few minutes back. Now I'm going to talk about the other solution, which is a software-based solution called Cisco Nexus 1000V. And give me 1 minute to switch between the windows here.
They may be looking for credentials again, I don't know.
So while Nexus 1000V provides a lot of additional functionality brings a lot of additional functionality, we want to showcase very simple demo here. We have 2 servers. Both are connected to the physical network, each running Windows Server 8, and one server has 2 VMs, an employee VM and a contractor VM, and the other host has a web server running on it. All of them are connected using Nexus 1000V. The idea is that we will configure port profiles or network policies on each of these VMs in such a way that the employee VM can access the internal web server, but the contractor VM cannot. So that's a very, very simple demo. The idea is to showcase how easy it is, both for the server admin as well as the network admin, to control such a setup. So let's look at the server admin's point of view. Give me 1 minute, guys. There's a small little technical snag here. I'm trying to connect to the server with the SCVMM on it, and unfortunately there's some...
It worked earlier.
Just the RDP is not working.
Yeah. We've had spotty connectivity.
That's the problem.
week.
Okay, let me... It's taking a little bit of time.
We have a backup video.
See, should I... Let me try one more time, and then maybe you can...
We're going to go to the video.
The demo god is not with me today. So it's not working.
No problem. Okay, let's switch back over here so I can see what I'm doing. Oh, not there. This one, yes?
The demo topology has 2 physical hosts,
You
with
want
each
control
running
Control it.
Windows Server 2012. One physical host has 2 VMs, an employee VM and a contractor VM,
You can grab
while the other has a web server running on it. All of the employee VM can access the interface from a CVMN.
Sorry, so this is how the actual SCVMM interface looks like. You have a cluster here with 2 servers on it, HV7 and HV6, and let me...
There's one cluster with 2 hosts, HV7 and HV6. HV7 has 1 VM running on it, there's a web server. HV6 has 2 VMs, an employee VM and a contractor VM. And these VMs...
Okay, he'll talk over it
Okay,
instead.
great.
Is that okay?
So the server admin can actually have a view of the network. So as you can see in the picture, both the employee VM and the contractor VM are connected to the Nexus 1000V, and you can see that right from the SCVMM user interface. This is the SCVMM 2012 SP1 bits, right? So for the network admin, the same topology, you can have a clear view so that is the interface for the VSM or the Nexus 1000V switch. So you can issue something like show module to see all the hosts that are connected to this particular switch. So as you can see, there are 2 hosts there, HV6 and HV7. Those are the line cards. And you can look at all the VMs that are connected to this switch by issuing show interface virtual. And as you can see, there are 3 VMs, employee VM, the contractor VM, and the web server. And as you can see, each has its own virtual Ethernet port, be it one for employee profile. So let's look at the profile configuration or the network policy for the employee VM. As you can see, there's a very simple port profile. all it does is puts the VM on the VLAN 20. That's a very simple port profile. So the employee VM is on VLAN 20. If you look at the policy configuration for the contractor VM, it's very similar to the employee VM. It assigns a VLAN 20, but in addition, it also applies an access list called deny blue client for both the inbound and the outbound traffic. So let's look at the configuration for the access list using show IP access list. So as you can see, there are the multiple rules, but the last rule is about denying web access. So it drops all the packets with the rule number 50, and it already dropped about 186 packets. And let's look at accessing this particular web server from the employee VM. All it's doing right now is just accessing the web server, and as you can see, you can access the web server from the employee VM. But when you try doing the same thing from the contractor VM, so there's an RDP session to the contractor VM, and you're trying to access the same web server, 120.1.1.10, and as you can see, it stopped. And now you can look at what's happened, what is the switch doing in this meantime, right? So you can see that the switch actually dropped the packets that met the rule number 50. So there were about increment of about 5 packets on this. So the idea is that with Nexus 1000V, if you already have any of the Cisco switches, you get the same functionality from Nexus 1000V. So the network admin has the same view. He can use the same ACLs, all the advanced features that you're familiar with on the Cisco IOS switches or Nexus switches are available in a Hyper-V setting for the network admin. And you can use the same interfaces, same management infrastructure. If you currently have any network management infrastructure in place to manage your physical infrastructure, the same can be applied for your Hyper-V environments as well. And a lot of the services that are available in the physical world, like NAM, ASA, VSG, all of them will be available for the Hyper-V environments as well. Thank you very much, Bob. Thanks for providing me this opportunity.
Good recover. Okay, we've got a few more slides we want to go through. I knew this was going to be packed. That's okay. Okay, so you've seen this screen a couple of times. If you're in the Hyper-V Manager, you can go to the Virtual Switch Manager, and you'll notice, in fact, that it's got several components in it. You'll always see the Microsoft NDIS capture. That's essentially the ETW extension, but it's not enabled by default. You actually have to you have to run some commands to enable it. And the WFP is always enabled. That's the Microsoft filtering platform. And you'll see here that we've got a forwarding extension, in this case the Cisco one. All of the management can also be by PowerShell, obviously. If you wanted, actually here's a quick snapshot of kind of the key PowerShell commandlets. Get VM switch will list all the switches that are on that Hyper-V host. Get VM switch extension, if you give it the switch name, will list the extensions for that particular machine. And then you can enable and disable the individual extensions on a per switch, per extension basis. I've talked about this a little bit as we've gone along here. There's a variety of different ways that you can implement traffic tools. You know, they can either be in a VM itself, they can be an extension, they can be a service that the extension talks to. You can use trunk mode to pump it to the VMs. You can, etc. You can create pipes, etc. So there's a variety of different mechanisms that we've built in 2012 to support additional traffic tools. ETW, here's the command, the netsh trace start scenario equals internet client provider equal Microsoft Windows Hyper-V VM switch. That will turn on the event tracing. Do whatever you do until you do a netsh trace stop, and then you can go ahead and look at the ETL log. In a similar fashion, you can turn on unified tracing. Let's say that events weren't enough. I actually now want to capture the packets themselves because something more is going on that I need to dive into. You'll notice that it just adds on the capture equals yes, capture type equal VM switch to that netsh command. Same idea until you do stop. Quick summarization of the benefits. It's a plug-in framework using known APIs. Don't need to rewrite an entire switch. It's got a quicker development. Native features are available with the extensions. Services are supported for the extensions. That includes all of the various NIC offloads as well as live migration. It's integrated management with both PowerShell, WMI, as well as the Hyper-V UI. You get a higher quality extensions because of the framework itself and because of the extension program, or the certification program. There's a bunch of useful links, tutorials on how to write extensions, samples, other documentation. There are some nice white papers out there. There are some videos about some of the vendors you've seen here today. And there are some other sessions that have some interesting related content that you might want to see later in the week too. In particular, looking, where is it? The bottom one actually will go into more information on how one actually uses SCVMM 2012 SP1 to manage extensions in great detail. Greg Cosenza's got a great session, so if you're interested, I'd suggest that. And the only other thing is to please do submit your evaluations. We look at the comments. Feel free to send me nasty grams if you want. And thank you very much. So we'll all be around here for questions. We've got a couple minutes.